sci-fi inspired tractor beams are real and could solve a major space junk problem. Researchers are developing a real-life tractor beam with the goal of pulling defunct satellites out of geostationary orbit to alleviate the space junk problem. In science fiction films, nothing raises tension quite like the good guys' spaceship getting caught in an invisible tractor beam that allows the baddies to slowly reel them in, but what was once only a sci-fi staple could soon become a reality. Scientists are developing a real-life tractor beam dubbed an electrostatic tractor. This tractor beam would not suck in helpless starship pilots, however. Instead, it would use electrostatic attraction to nudge hazardous space junk safely out of Earth orbit. The stakes are high. With the commercial space industry booming, the number of satellites in Earth's orbit is forecast to rise sharply, and this bonanza of new satellites will eventually wear out and turn the space around Earth into a giant junkyard of debris that could smash into working spacecraft, plummet to Earth, pollute our atmosphere with metals, and obscure our view of the cosmos. And if left unchecked, the growing space junk problem could hobble the booming space exploration industry, experts warn. The electrostatic tractor beam could potentially alleviate that problem by safely removing dead satellites far out of Earth orbit, where they would drift harmlessly for eternity. And while the tractor beam would not completely solve the space junk problem, the concept has severe advantages over the other proposed space debris removal methods, which could make it a valuable tool for tracking the issue. Tackling this problem, according to what experts said. A prototype could cost millions and an operational full-scale version even more, but if the financial hurdles can be overcome, the tractor beam could be operational within a decade, its builders say. The science is pretty much there, but the funding is not. Project researcher Kaylee Champion, doctoral student in the Department of Aerospace Engineering, University of Colorado Boulder, says, the tractor beam, depicted in Star Wars and Star Trek, suck up spacecraft via artificial gravity or ambiguous energy field. Such technology is likely beyond anything humans will ever achieve, but the concept inspired Hans-Peter Schaub, an aerospace engineering professor at CU Boulder, to conceptualize a more realistic version. Schaub first got the idea after the first major satellite collision in 2009, when an active communications satellite, Iridium-33, smashed into a defunct Russian military spacecraft, Cosmos 2251, scattering more than 1,800 pieces of debris into Earth's orbit. In the wake of this disaster, Schaub wanted to be able to prevent this from happening again, and to do this, he realized you could pull spacecraft out of harm's way by using the attraction between positively negative charged objects to make them stick together. Over the next decade, Schaub and colleagues refined the concept, and now they hope it can someday be used to move dead satellites out of geostationary orbit, GEO, an orbit around Earth's equator where an object's speed matches the planet's rotation, making it seem like the object is fixed in place above a certain point on Earth. This would then free up space for other objects in GEO, which is considered a prime real estate for satellites, Schaub said. The electrostatic tractor would use a service spacecraft equipped with an electron gun that would fire negatively charged electrons at a dead target satellite, Champion said. The electrons would give the target a negative charge while leaving the servicer with a positive charge. The electrostatic attraction between the two would keep them locked together despite being separated by 65 to 100 feet of empty space, she said. Once the servicer and target are stuck together, the servicer would be able to pull the target out of the orbit without touching it. Ideally, the defunct satellite would be pulled into a graveyard orbit more distance from the Earth, where it could safely drift forever, Champion said. The electrostatic attraction between the two spacecraft would be extremely weak due to limitations in electron gun technology, and the distance by which the two would need to be separated to prevent collisions, project researcher Julian Hammery, doctoral student at CU Boulder, said. So the servicer would have to move very slowly, and it could take more than a month to fully move a single satellite out of GEO, he said. That's a far cry from movie tractor beams, which are inescapable and rapidly reel in their prey. This is the main difference between sci-fi and reality, Hamre said. The electrostatic tractor would have one big advantage over other proposed space junk removal methods, such as harpoons, giant nets, and physical docking systems. It would be completely touchless. You have these large dead spacecraft about the size of a school bus rotating really fast, Hamre said. If you shoot a harpoon, use a big net, or try to dock with them, then the physical contact can damage the spacecraft, and then you're only making the space problem worse. Scientists have proposed other touchless methods, such as using powerful magnets, but enormous magnets are both expensive to produce and would likely interfere with the service's controls, Champion said. The main limitation of the electrostatic tractor is how slowly it would work. More than 550 satellites currently orbit Earth and GEO, but that number is expected to rise sharply in the coming decades. If satellites were moved one at a time, then a single electrostatic tractor would not keep pace with the number of satellites wrinking out of operation. Another limitation of the electrostatic tractor is that it would work too slowly to be practical for clearing smaller pieces of space junk, so it would not be able to keep GEO completely free of debris. Cost is another big obstacle. The team has not yet done a full cost analysis of the electrostatic tractor, Schaub said, but it would likely cost tens of millions of dollars. However, once the servicer were in place, it would be relatively cost-effective to operate, he said. Once the team is ready, the final and most challenging hurdle will be to secure funding for the first mission, which is a process they have not yet started. Most of the mission costs would come from building and launching the servicer. However, the researchers would ideally like to launch 2 satellites for the first tests, a servicer and a target that they can maneuver, which would give them more control over their experiments but also double the cost. If they can somehow wrangle that funding, a prototype tractor beam could be operational in around 10 years, the team previously estimated. Is it viable? While tractor beams may sound like a pipe dream, experts are optimistic about the technology. Their technology is still in the infancy stage, John Krasidi said, an aerospace scientist at the University of Buffalo, New York, who is not involved in the research. He said, but I am fairly confident it will work. Removing space junk without touching it would also be much safer than any current alternative method, Krasidi said. The electrostatic tractor should be able to produce the forces necessary to move a defunct satellite and certainly has a high potential to work in practice. Carolyn Frew, Associate Professor of Aeronautics and Astrophysics in Purdue University, Indiana, said, but there are still several engineering challenges to be solved along the way to make it real-world ready. Scientists should continue to research other possible solutions, Krasidi said. Even if the CU Boulder team does not create a final product to remove non-functional satellites, their research will provide a stepping stone for other scientists, he said. And if they are successful, it would not be the first time scientists turn fiction into fact. What is today's science fiction could be tomorrow's reality, Krasidi said. And this is by Harry Baker on Live Science. Please leave your comments. Thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.